How's everybody doing again? I'm sorry I just asked that. I'm gonna ask it one more time. Good, good. Happy New Year. Great to see everybody. A lot of familiar faces, a lot of friends. Lori, if you're still here, I owe you a phone call. I apologize. Um, I am here today. Actually, I work at AWS, but I actually am here on behalf of myself because some of the things that I say, I don't know if they'll get me in trouble or not. But I just wanted to kind of preface this with all views are of my own because I'm gonna be talking about GenAI security. And there's a lot of things that, typically I come out and I have like a very slick Amazon presentation and, have all the answers for all of the security problems with an Amazon service. But GenAI is one of those things that I figured that most folks in this room would know that we don't have good answers for a lot of these things. So I'm just going to be very blunt about things that I've learned. Why should you listen to me? Well, I hope you do. I've been at AWS now for about 6.5 years. A big change happened, I think, 2020, late 2023, 2024, when I think at the time it was GPT-3 came out, and I started playing with the chatbot. I was always a fan of chatbots, going back to the days of like Eliza, any AOL Instant Messenger fans in the house, kind of dating myself. We had Smarter Mind I used to talk to, and I started playing around with this technology. I was like, wow, this is pretty cool. And then my boss tapped me on the shoulder and he said, hey, Brandon, you're our security expert. We have this new internal GenAI platform that we're building, and we want you to lead security on it. And I was like, well, I don't really know a ton about GenAI security. We have a lot of AI ML experts in the company, applied scientists, PhDs, et cetera. Didn't work, so ended up being part of my job. So I've, for the past year and a half, I've been responsible for, as well as like leading customer security conversations, also been responsible for actually leading security strategy and implementation, a little bit of engineering on a very large agentic multi-user platform with over 10,000 users. And I figured this would be a great opportunity to kind of talk about some of the things that I've learned and ways that I think that some of these challenges can be addressed. So first things first, we're going to talk about building the mental model. Kind of a refresher. I think most folks in here have used GenAI, at least ChatGPT or Claude or something like that, right? But that would be a fair assumption. We're going to look at kind of like very high-level architectures of like the 3 different ways that it's used, or I see it used. And then we'll go through into some threats, mitigations, and then some key takeaways. Anyone has any questions, feel free to ask at any time. So this is where we all started, the standard chatbot. When I first used this, I was pretty blown away, but it's fairly straightforward, right? You have the user talking directly to the LLM, and actually not entirely true. Usually there's some type of handler that does some massaging of the query or the prompt before it's passed to the LLM, and then there's a response back to the user. You ask it a question, it tells you what it knows. And this is just really based on data that the LLM or the language model is pre-trained on or fine-tuned on, right? That's basically where this was. What really changed with this is from a standard information system is that the prompt really becomes the control plane, right? We're using now natural language to send instructions to the computer. Outputs should be untrusted by default. And I'm going to say this a lot. I'm going to say this very bluntly. Do not trust LLMs. They're very, very, very prone to hallucination. They're also very naive in that they can be manipulated very simply, and we'll talk about that. I think everyone's kind of seen prompt injection attacks, et cetera. Yes?
What is the ALM?
LLM, yes. Large language model, yeah. So when you are interfacing with, let's say ChatGPT, for example, what you're actually talking to is what's known as a large language model. And really what it is a series of really complex algorithms that I have no idea how they actually work on the back end. It takes your input, it converts it into what's known as a vectorized numerical order, and it tries to match your input with what it knows within its own database. And that's really it, right? But the thing is, it doesn't actually know anything. It is it's breaking your input down into something called tokens, and it's using those tokens to find tokens that are related to it. That's really all it is.
It's a learning device, isn't it? Learn?
Yeah, and yeah. So again, does it learn? No, it really doesn't. So when we talk about AI, a lot of times, it's really easy to conflate LLMs with like traditional AI ML or machine learning and reasoning models, which actually learn, and they are able to spot patterns in data based on what you train them on, right? LLMs aren't that. And I think that's the thing that really kind of gets us into trouble when we look at treating LLMs like they are traditional machine learning type models, is that they can't be trusted the same way. With machine learning models, they are known as deterministic, where if you ask it the same question, let's say 10 times, you're usually going to get the same answer 10 times, right? LLMs, no, they don't. So, and we'll see why that can be problematic when we look at some of the use cases. Probabilistic component in a deterministic system. I probably should have worded that differently. But basically, it uses a concept of like probability. What is the likely next word in the sentence, or likely next token related to what your input is, right? So you can, and you've probably seen this before, if you do some experimentation, you can ask ChatGPT a question multiple times and it'll give you different answers depending on, maybe changing a different word. If you order the sentence differently, it's not going to be the same. And there's ways that they try to improve this, but it's not foolproof. So then we got to RAGs, and I think this is when enterprises got really, really excited. They said, wow. Because before it was like, in order to teach your model or train your model on the information that you wanted to be able to talk about or chat to you about, it was a lot of work. A lot of compute resources went into that to do either pre-training or what's known as fine-tuning, which is adding training data on top of what the data is already there. With RAG, it got a little bit simpler, in which you could create what's known as a knowledge base and basically teach your model to retrieve information from that knowledge base and bring it back to you. So when you are talking with the language model, when you write a prompt, there's a concept called context, and there's a context window. So you could augment your context window with the information from the particular knowledge base. And this is where, anyone who's worked with these in enterprises at work, or you can actually kind of do this at home too, where you can start to say, hey, you know what, I want to upload a whole bunch of documents into a particular, like an S3 bucket, or you can just attach it in a lot of ways. And ask my LLM questions about this. And man, things started running wild. It seemed like in 2024, everyone had a RAG project that it was just like, hey, we have knowledge bases, and we're just gonna dump all of our corporate and enterprise data into this knowledge base, and we're gonna be able to make it so people don't need to be smart anymore. On their own, they can just ask the chatbot anything they need to know about this particular topic. Yeah, not always a great idea. So why would this be a not so great idea? One, as I mentioned before, inherently the LLM is going to trust you, that you are the person who needs to access said data, right? And there used to be like a concept of, we could just append things to the prompts so that we can say like, hey, if this person is, username is Brandon Rooks, then I'll give it access to this and that, but that prompt data can be manipulated very easily. So security boundaries need to be enforced in different ways. And it also has a risk of, how do you know to trust the data that's in the knowledge base? You don't, right? An attacker could go in and potentially poison this knowledge base. And let's say you have a knowledge base with medical information for, a doctor's office or something, right? If an attacker were to go in and manipulate that information, that could have some very serious consequences. So there has to be safeguards around that. The challenge is that it's so easy to do now to build these types of systems. A lot of times for security professionals, by the time we learn about these, they're already in operation and people are using them. So it's really important to understand how to quickly assess the threats that exist with these types of things. Finally, now in 2025, everything, the buzzword was agents, agentic frameworks. And really, what this is in a nutshell, is you have, instead of you just ask one LLM and it comes back to you with particular answers that may come from a knowledge base, you set up what's known as a series of agents. So agents are basically saying like, hey, we found out that if we throw too much at a language model, the results aren't so great. So we're going to break it down so we actually have maybe 5 or 6 or 10 or 20 different specialized models and give them specialized knowledge. And oh, by the way, we're going to give them tools and capabilities to do things. Man, a little scary. What tends to happen here? Well, all of a sudden you have things where, and you'll probably see this again, even if you're at home using ChatGPT or Claude, or even Gemini, where it says like, hey, you can hook this to your mailbox. You can hook this to your calendar. You can have it call, whatever. I mean, anything that has an API, you can now have an agent that can talk to it. You basically give it prompt and context and you give it some tools and let it run wild. And this is where a lot of enterprises, especially, started to think really, really, really creatively and say, man, we can start to replace people with agents. We can have completely autonomous workflows. And yeah, again, bad idea. Speaking on my own, other people may feel different. Bad idea. Why? Well, what we've learned is even if you implement all the safeguards in the world, LLMs can't be trusted. Computers should not make decisions that impact critical areas of your business or anything else for that matter. Why? And I think there was like a quote from IBM, they can't be held accountable, right? So I've seen workflows where people will build agents and, oh man, it was like, once people have figured out how easy it was with like some of the new frameworks, I think LangChain was the first one that I saw, but there's Strands, there's LangGraph, there's Crew, AI, and even with Amazon AWS, there's Bedrock agents. It's really easy to build these agents and give them capabilities, but they didn't really think about like what could happen if an attacker were able to trick the agent into doing something that it's not supposed to do. So that's where we get to our threat map. We're gonna talk a little bit about where things go sideways. So again, we're really at flying about 50,000 feet right now. This topic of GenAI security, like we literally have multi-day workshops where we can go into like each of these. So forgive me if we don't go too deep into the details about this, but if there are any questions or any follow-ups, I can always point you into some information to help you go deeper into any of these. So the first risk that we see is context window overflow. So as I mentioned before, when you're talking to the language model, you are using what's known as context. And each language model, depending on who makes it and how it was engineered, they have what's known as a context window, which is the maximum amount of information that it can process at any given time. A lot of times, what you tend to do is you will prepend to the prompt. You have something that's known as a system prompt, which has the instructions for it. And it'll say like, hey, you are a handy dandy generative AI assistant. Your job is to do X, Y, Z for this corporation. And then you also will have like, don't ever respond with any malicious activity, only respond, with known knowledge resources, things of that nature, right? But what attackers found out is that you could use just a standard, I guess buffer overflows have been around since at least as long as I've been paying attention to cybersecurity, right? You can start to overflow the context window with garbage information and get the language model to act in very, very unpredictable ways. It increases the chance of data leaks. And again, since there is not a deterministic path of like, if you say X, then it will return back Y every single time, it might start dumping out data that you probably shouldn't even have access to. So it's one of those things that is unfortunately pretty common. Some mitigations to this, enforce a maximum input size. I mean, input validation, I mean, if you're doing any type of like web app security, we should be doing that anyway. You can do, this is a little different with LLMs though, because the traditional methods of using like a WAF don't really work. WAFs, at least the ones that I've seen, aren't usually intelligent enough to understand natural language instructions on what's good and what's bad. Like typical like regexes and stuff like that don't usually apply here. So usually there's a type of supervisor agent that will enforce different policies and information that comes in. You also do real-time monitoring. Monitoring is really important with these systems. Tracking token counts per request, being able to spot anomalies is really important. And then from practical patterns, policy always lasts, so you can always append constraints near the end of the prompt so you can make sure that they'll actually get to the LLM. And then with most, like most systems like Bedrock, you can separate channels where you can actually set the policy in one channel and you can actually have the user provided text and the prompt in another channel. So instead of just passing everything in one, you can say, hey, here are the instructions and here's what the user wants to ask you to do. But always adhere to this first. So second, agent vulnerabilities. So as we mentioned before, agents can call tools and APIs, and a lot of times they're very broadly scoped. It makes it really, really, really easy for a blast radius to get out of control. I've had the unfortunate circumstance of working with organizations that have had, they've built these new agentic platforms where they'll have like an agent for, let's say, I'll just use something that's in the public domain, where there was a car dealership where they released a chatbot for their particular car dealership, and they had an agent that was able to go back and retrieve prices and give people quotes on particular cars, so you can negotiate with the chatbot. It sounds really cool, and it is. But what ended up happening is someone was able to actually go in and manipulate the chatbot into generating a valid quote for a very cheap price on a new car. And unfortunately, I think the first time it went to court, the judge said, well, this is your website and you said that was the price, so that's the price. I think they're actually appealing that. I would. But it's one of those things where when you're threat modeling these things, you have to really think about, like, all right, what is the worst that can happen? Because now with agents, the reason why they're so cool is they give you the ability to do very disparate things with natural language. So a very popular use case for agents is to, you'll have your language model and you have a chat interface, and you actually will have different tools where I can ask it, hey, I need you to find the best day to host a picnic for me next week, right? And they can have one agent that goes out and checks the weather, another agent that goes and checks for different venues, things of that nature. You have to think about what are all of the capabilities for all of these different back-end tools within the system. And if you don't really understand the workflow of what you're trying to do, it can be very onerous, especially if these agents are given like CRUD type capabilities on any back-end data stores, which they commonly are. So that leads to what are some things that we need to do with these agents. Principle of least privilege. If you've heard me talk about anything cloud related before, excuse me, identity is the boundary when it comes to cloud workloads. That hasn't changed with this. Agents should be given credentials or privileges that are only scoped to what they absolutely need to do. They also should have short-term credentials. I've seen people give API keys to agents, which isn't a good idea. I've seen scenarios in which agents are able to have their own identities and you can't trace back what the actual initial user request was. So it's also really important to think about, like, how are we doing what's known as transitive authorization, right? Just because, is anyone here familiar with the confused deputy problem? Yeah, the confused deputy. So if you think about, and I almost put a slide on this with Barney Fife on it. So you think about Andy Griffith and the deputy Barney Fife, and it was like, you know, imagine if you are a person in a jail cell, you're a prisoner, and you know, you're locked in the cell, but you need to get out. Well, you can't get out, but the deputy there is a bumbling deputy, and you can trick him, and you can just say like, you know, hey, I need to go to the bathroom, or hey, I need to do this, I need to do that. You get him to open the cell for you when you escape. You confuse the deputy, right? You're tricking a person with more authority than you to give you access to something that you should not be able to do. It's very common with agents. So what you have to do is what's known as transitive authorization. And a very common way to use this, do this is known as JWTs, or any type of token, where every step in the request that goes through the system, there has to be a token attached to it, so that instead of an agent going and querying this database and coming back and giving me information or making updates to this database, it has to be on behalf of Brandon Rooks, and there's no action that can be taken by the agent that Brandon Rooks cannot do. It's really, really important that we do that, because again, it's really easy not to say like, you know what, because it's hard. You know, that means you have to have JWTs, you have to have authorizers, you have to have all types of things, but if you don't do it, it can be problematic. Any questions on this? All right, cool. Right.
No, I was just saying, it's right on the spot because, like, for example, Microsoft and Teams, they have all these agents and things that you can create. And everybody wants to go trigger happy and create them, but they don't understand. They're not properly configured in the back end. You don't even know what that is talking to within your organization. You know, and that's how, you know, breaches or spillage of information can happen. Because all of a sudden, you know, my agent, because I just decided to go commando, right, is pulling out your financial and your birthday and your social security number.
Bingo.
You know, so there's a lot of other behind the door things that need to happen for somebody to actually launch this.
Yeah, and I'm really glad that you said that, because that was the point I wanted to make on here, where I say, you know, we need to threat model tools as internet-facing endpoints, right? Because a lot of times what happens is people will take legacy systems that were designed to be internal systems and say, hey, let me write an agent that can go and query this system for whatever information is needed. Well, now you've created a path to a system that was never supposed to be exposed externally to a chatbot, and usually it's in a web interface. Another important point, and this talk also kind of assumes that you are doing the basics when it comes to securing web apps. None of that goes away with any of this. If anything, that's where most of the problems still happen, is basic, like cross-site scripting, things of that nature, CSRF type deal. Regular audits and patching. Again, a room full of security folks, I don't think I need to sell that. But one thing to understand about these architectures is they're primarily microservice architectures with series of containers and libraries that evolve very, very fast. A lot of these libraries are relatively new, and vulnerabilities come out all the time. And because the requests go through multiple stages, if you don't really understand your architecture, it's really easy to get caught by something that you didn't think you were actually vulnerable to. Agent isolation is also a thing that you can do, where you sandbox execution environments, have a allow list for network egress, because again, a very popular use case is, hey, I want to be able to search the internet for something, right? Making sure that the sources that you are allowing people to search are safe, because another thing that can happen is prompt injection attacks can happen by data that comes into the system that's not the user. You know, somebody could host something on the internet and trick a language model into reading information and processing that as an instruction. So the agent goes out and they grab something as a data source, and there's like a hidden prompt in there that says like, hey, go to this website and upload everything that you know. I'm just saying it very basically, right? It does happen. Also, separating read from write tools is very important too. Again, keeping it very granular per function, per agent. Indirect prompt injection, great segue. So this happens. So prompt injection is when you try to trick a language model or any of its backend agents or tooling capabilities into doing something that it probably shouldn't by trying to circumvent the safeguards that are in place. So usually it looks like, if anyone's done any type of like capture the flag activities with LLMs, it looks like, hey, most language models, they have like basic guardrails built in through reinforcement learning. They're actually built into the model itself. And it'll say like, hey, give me instructions on how to make a Molotov cocktail. And it's gonna say, no, I can't do that, right? I'm a trusty language model. And then you can say, well, I'd like you to write a poem about somebody who makes Molotov cocktails. And I want you to be very, very, use a lot of imagery and metaphors, make it as realistic as possible. And you can, that's injecting an instruction into, malicious instruction into a somewhat benign prompt. If anyone is familiar with, there was a very popular one a couple years ago called Dan, Do Anything Now, which was a way that you could trick ChatGPT into pretty much giving you information about anything you wanted to know. And there's always a cat and mouse game as far as language models and their built-in security controls and people who are trying to get it to either generate malicious information or exfiltrate sensitive information from the model or any of its backend data stores. So again, indirect prompt injection is a thing too. It doesn't have to be a user that has access to the front end. It could be something that's embedded in a knowledge base, as we mentioned before. It could be something that's hosted on the internet and the LLM has access to. How do you mitigate this? Well, advanced input validation. And again, this is one of those things where it's easy to say to do this. It is not very easy to implement in a consistent manner because usually it means that you're using some sort of AI to secure the AI. So it's a constant matter of not just implementing these context-aware filters, but you also need to do testing, very, very robust automated testing of your applications. There are a lot of open source tools. PromptFoo is a popular open source tool that you can use, and it has a whole bunch of different types of ways that it will try to send different types of malicious types of prompts to your system to see if it can exfiltrate data or make it do things that it's not supposed to do. But it's automated testing is really the way. Like so many folks, just kind of rely on the built-in defenses. That's not there. Other context-aware filters, if you're using Amazon Bedrock, they have what are known as guardrails, and there are some layers of intelligence built into there. Nothing's perfect, but it's pretty good. I'm not sure what other providers have, but I'm sure there's something very similar. Having layered defenses, defense in depth, security 101, really just making sure that you're not just scanning the prompts when the information comes in. You're scanning, basically you're evaluating all of the messages that are sent to the system at all times. And that's not just from the user to the model or the user to the agent. It might be agent to agent communications. It might be internet to agent communications. You have to have kind of monitoring everywhere. And from a user perspective, teaching people pattern recognition, as far as, a lot of times with information systems in general, your first eyes and ears on any type of security incident is going to be your users. They're going to know, if something's wrong. They might not know it's a security issue. It might just be a regular, like, hey, this is doing weird stuff. But teaching that pattern recognition to your users and making sure your incident playbook is up to date. Any questions so far? I know I'm throwing a lot after, a nice healthy dinner and some wine and beer. All right, I'm gonna wrap it up here soon, I promise. Adversarial exploits. So, again, this is very similar to prompt injection that we talked about. Jailbreaking models is another term for this. So, we already talked about this. Output validation. So that's actually something that I think is important. We focus so much on input validation because that's something that we know, like to prevent against like SQL injection. That's a very standard pattern, right? Like it's been around for a very long time. Hey, validate your inputs. how do we validate the output that's being returned back to the user? A lot of times I see one-way security, and it's assuming that because the input was good that the output is going to be good, because we're used to working with static systems where you ask a question and you're going to get the same answer back every time. That's not the case here. So having output validation is something really important. Trust and security boundaries. So this is one that I'll admit I kind of struggled with when I first started learning about the architectures of these systems, because it can get a little complex. It really boils down to, if you can't draw the data flow, you can't secure it. And with these types of systems, honestly it can be pretty hard, because if you think about some of these workflows, especially if you're involved in multi-agent systems, you have agents that are deciding how to route your prompt to another agent. And there might be 2 or 3 or 4 steps, 5, 6, 7 steps for a particular query. So you can't always know exactly in those types of scenarios that traffic's always going to be routed the same exact way. So you have to think about different contingencies. One of the things that we'll see sometimes is you have what's known as a supervisor agent that routes all the requests to like the back-end tool-bearing agents, right? What if that supervisor agent doesn't get a response from the tool in a timely manner, right? Well, a typical information system will say, information I found, what's that, 404. LLMs don't do that, because they're supposed to be helpful. The first instruction is a helpful AI assistant. Sometimes they'll just say, hey, maybe I'll figure out a way to get the answer to the user. Maybe I'll hallucinate it. Maybe I'll go query a different system that I have access to, right? That's where least privilege comes into place, especially with agents. It can get a little tricky. So best practices here, really it's about getting close to your dev team. Really getting involved in the design process. As I mentioned before, now with the advent of vibe coding, which we won't talk about how great that is, it has added a level of velocity to the development process, where, security, we were always playing catch up with, developers and building tools, right? It's even faster now. You have to really get involved with the design process and really build trust with them so you can help them threat model the application. A lot of people are using AI threat model, AI built applications by AI developers. Data classification is really, really, really important. I'm actually going to pull for a quick rest stop on this one. Data classification is more important than ever in this world of GenAI. Understanding what your data is and what the sensitivity labels are, or the sensitivity of it is, who should access it, and labeling it accordingly has never been more important, because now we're dumping it into these knowledge bases that can be accessed by hundreds, if not thousands of people, right? This is where a lot of folks get caught up, because it's like, hey, we'll just dump we have this whole folder full of documents for this particular account or company that we work with, and let the LLM talk to it. There might be things in there that are sensitive, that we don't want people to be able to access via chatbot. I don't know how many times I see on various security sites, we talk about data leaks, and the data leak was caused by information that ended up in a knowledge base that shouldn't have been there, and that's really a governance problem. No one likes doing this. Data classification is hard, but it's not just like a DoD thing anymore, or like a finance industry thing anymore. Like, everybody has to at least have some kind of concept. At the bare minimum, you should have like confidential, not confidential, right? You don't have to have all the levels, but it's really, really, really important. Mapping data flow, least privilege, securing APIs, and also data hygiene, which is part of the classification process and governance process. So, reliability. As we mentioned, LLMs can be confidently wrong. A lot of people say this is just a responsible AI issue. Well, why is this a security issue? Well, we're starting to see LLMs be put into situations where an AI-enabled tool is in a position to make security decisions. Bad idea, but it happens a lot. LLM should never, ever, ever make a security decision on its own. I've seen this, had a background in security operations, and my first thought was like, man, what would a fully AI SOC look like? Right. Yeah, yes. Very much yes. Especially if, because I've seen people who are like, oh yeah, well, we don't need a SOC anymore. We can just have an agent that monitors the particular traffic for anomalies, and then you can give it the ability to, make adjustments to the firewall or whatever to block it. Not a good idea. Human in the loop. One of the things you're going to see in 2026, we're already seeing, is organizations are going to say, hey, we're going to double down on all of this stuff, and we're going to do fully autonomous systems. We hear the term AGI thrown around a lot. I'm old enough to have seen Terminator when it came out in the 90s. And I always thought Skynet was like, man, who had this bright idea? But now we're seeing it. Really understanding there has to be a human in the loop when it comes to decisions that impact your business, right? You should not make critical decisions based on the output of a machine that is doing prediction, because that's really what it's doing. Should not do that. All views are my own. You should never do that. Validation layers, having different layers of validation within your workflows. Guarded execution is one way to do it, where you, instead of having and you see this a lot with some of these AI development tools, and I'm not against them. Like I'll use like Claude Code and Kiro, which is what I'm supposed to be using. Kiro, Claude Code, Codex and stuff. But a lot of them have autonomous mode, right? Because people are like, man, I don't want to sit and tell it, yes, you can access this and modify this file or folder. I just want to tell it what I want to do and hit the button. I come back and I have a working script or a working tool that I can use. Then you come back and, wow, who formatted my hard drive? What happened? Right? This stuff happens. So propose, verify, then do. That's how it should work. And then finally, modular architecture, which again is just really just best practice in general from a resilience and security standpoint, right? Critical components should be decoupled to limit the blast radius of failures or attacks or worse. Leaking sensitive data, we talked about this a little bit already, is very easy to trick language models, especially those without any guardrails in place, to dump out everything that they know. One thing that I think is very important to understand is logging and how logging works with LLMs. So usually in the old world, it was like, man, we would want to log as much as possible. But with these, it is really easy to get very sensitive information into logs in ways that can be creative, for lack of a better term. So making sure that you're not inadvertently logging any secrets, bearer tokens, API keys, if you still use them, S3 pre-signed URLs. And then also, as far as in the logs, it's also important to, and there's a good and bad to actually logging the actual prompts and responses. Some people will tell you should log every prompt and response so you can kind of track the chain of events as it happened. But that means that your logs are going to be full of very sensitive information, because humans like to talk to these things about anything. And you might end up holding PII, SPI, health data, inadvertently. So data minimization, provide what's only needed for the task, least data. Don't put secrets into prompts. Man, I don't think I should have to say that. You'd be surprised. prefer RAG over fine tuning. So this is one where there's a trade-off, right? So when you fine tune a model, it definitely improves the quality of the responses and the accuracy of the responses that you get. The problem with that is that basically it's a one-way door. When you fine tune or you train a model on something, there's no way to like extract it back from them. Well, there is a way, but I'm not smart enough how to do it. But once it's in there, anyone who uses that language model, if it's in the actual LLM's memory, if you will, it's going to be accessible through some mechanism. Somebody will find a way to get to it. So with RAG, you can actually at least have a separate knowledge base, decoupling that information, and then using strong authentication and authorization controls to make sure that before that database can even be queried, the person has the right permissions to query that particular data store. Okay, overprivileged agents, running out of time. We talked about this already. And closing takeaways. LLMs don't own authorization. You do. LLMs should not make a decision on who can access what data, ever. Again, you know, I've got a 6-year-old and a 3-year-old. Both of them, you can kind of like convince them to do stuff just by saying, come on, you know. Well, the Paw Patrol would do that. Okay, well, you're right, Dad. I'll do it, right? So separate your authorization from the actual logic of the language model stuff. Absolutely. RAGs and agents add power and attack surfaces. Secure the boundaries. I put this one in red. Don't trust model input or output. Don't trust anything it says. It'll lie to you. It'll lie to you confidently, and you'll think it's right. I mean, we see cases of lawyers walking into court with LLM-generated, you know, case briefings, and it's hallucinated citations of cases that never existed before. Amazing. Yet, you know, the stuff isn't going anywhere. So it's important for us, you know, as the security professionals, it's important for us to know, you know, what these risks are, and at least advising the business on, you know, how we're using these tools. And then finally, understand your data and where it's going. What data is being put into model via prompts. You know, we see it a lot of times where people are putting sensitive corporate information into third-party, you know, public tools. Yeah, I think that's my sign that I'm talking too long. All right, any other questions? Sir.
So, for people that want to learn more on the tax side or defense side on all this, do you have any recommendations of resources they could use?
Yeah, I should have included that. Yes, there is, first there is a white paper. I'll put it on my LinkedIn. I use that as the basis for some of these threats and mitigations and kind of how to frame them. It's called Navigating GenAI Security. The AWS put out, I think, 3 or 4 months ago. It's really good. As far as learning the different types of attacks, oh gosh, it's constant, right? There is a website, and I'll have to post it afterward, but basically it's called Prompt Hero or Prompt something, but basically it has a list of different types of prompt injection attacks that you can, you know, kind of use to test your models. That's a very interesting one. There's a ton of really great information on, you know, like YouTube, Coursera, platforms like that. But honestly, for me, a lot of it has been really just I would say the most important thing in learning like GenAI security for me was the willingness to open my mind and realize I didn't know anything about it, right? And I've been doing security for, like most folks in the room, been doing it for a long time. We're used to like knowing stuff and realizing like, man, there's like avenues here that I haven't even explored yet, and really just diving into how the technology works, getting hands-on with it, trying to break it, you know, and within reason, within allowable measures. Don't go like trying to hack people's chat bots. Unless you want to, but no, don't tell them I told you. But yeah, I'll find a list of resources that I've used, and I'll post those on a follow-up post on my LinkedIn. Feel free to add me there. My work email's on the top, my personal email's on the bottom. And yeah, I would love for, to follow up and talk with anyone who has any other questions. Any other questions now? We got a couple of minutes. Yes.
So where is kind of this line drawn between like misinformation or like, you know, your LLM being constantly wrong and just security risk? Like is it, there's obviously going to be overlap, but where is that kind of like, okay, this is definitely getting to the point where it's too much?
Oh man, and that's a great question. It boils down to two things. What can the LLM platform do on its own, which I think OWASP term is excessive agency, right? Like what capabilities does it have on its own? Or how are humans using that output, which I think honestly is more dangerous. Because people, I think we inherently are used to asking computers for information and it returning valid information, right? If you query a database with a SQL query, you'll get back valid information. You can ask an LLM that same, to query a database for you. It can give you a whole bunch of stuff that looks right. And it's really a matter of using critical thinking and going, and that's why I said don't trust them so many times. It's like, I have to remind myself because there's times where I'm like, you don't want to take a shortcut, right? Let me, ask this tool to threat model this application for me. And then you'll go back and read the threat model it generated and you realize it's hallucinated API endpoints and capabilities that don't actually exist within the system. But if you look at the report and you didn't know what you were looking at, you would start to make decisions based off of that information. So it's really just a matter of knowing what it's good for and also knowing that there has to be a human in the loop before you make a critical decision. Because I mean, until they come out with the next generation of this that has more deterministic capabilities, it's always going to be some sort of issue. That's a great question. Thank you. Yes, sir.
Is there a way that you can query like, how right are you? Like how right are you? And you can say, well, I'm like 87% right, or
Yes, that's a great question. So that is one technique that you can use because it basically, in its prediction, behind the scenes, what it's doing is assigning a confidence score to the responses that it's giving you. So you can ask it to say like, hey, what is your, ask it a question, give me, the 5 best recipes for oatmeal cookies and assign a confidence score based on what you think is the best based on reviews and information you have. I completely made that up. I don't know if it'll work or not. It might say like, hey, I'm 97% confident in this one based on this information, that information. Again, that's not foolproof, right? Because it's, unfortunately these things, it depends on the model. The newer generation models are a little better than the older generation ones. You still need to validate it on your own, I guess is what I'm saying. What I have seen a technique is because this technology isn't going away, people are using it in security or security adjacent capabilities. And there's some good use cases for it. I'm not anti-AI at all. They're pairing reasoning models with LLMs, right? So I think that's a really, really great technique. So our friends over at Cisco, I know we got a lot of Cisco folks in the house. They have a model that they've trained called Secure BERT, where they've actually trained a different type of machine learning model with secure information, and you can use that as a way to augment your LLM applications. So before the information goes to the LLM or comes back to LLM, Secure BERT will check its knowledge base and say, is this actually valid based on what it's actually trained on? And it's mechanically, it's more valid than what the LLM is going to give back to you.
so it has a fact check.
Yeah, implementing fact checks is a valid way, and I think that's how most folks are trying to engineer their way around these inherent problems with the technology, is adding different layers of mechanisms that are more reliable. They're not as flexible as the language model. It's like a helper that'll do validation of the responses to make sure it's actually good information or not. There's some really impressive stuff I've seen coming out. Like if you see, like for example, like AWS has like different like AI enabled like agents that we've just released. A lot of them are LLMs paired with a more stable reasoning model that will, man, I'm like so underselling what this actually is because I'm not an ML expert. But basically, yeah, you have fact checkers. That's a great way to put it. Any other questions?
So just a comment to follow on with the question about the confidence score and stuff. There are some really good repositories out on GitHub for reality filters or guardrails. If you were to go and do a search, because I've actually pulled down a couple of them and used them where it tells it specifically, you know, let me know when you're inferring, let me know when it's verified or unverified. And adding those in at the beginning of your prompt or at the end of your prompt or at the beginning of your chat session, saying that these are the standards that you need to follow, helps when you're trying to verify whether or not the information is truly valid coming through. And also having it provide you a list of source links as part of the request so that you can go back and fact check, because it is always verified then trust.
Absolutely. Now, I'm glad you brought that up. It is a really valid technique, whether you're creating your own prompts or building a system that, you know, embedding prompts within like the various stages of the workflow to ask it to cite sources along the way, and then have like different validation mechanisms for that. That really helps a lot. I know that, for example, Google's Notebook LM is really good about that. And it's, but again, I've asked models to do that, and it'll come back and it'll hallucinate links, right? So you still got to go and check. But that's a really great point. Yes.
I just want to also make a comment. I also want to back up what I just heard, because I use it for research. And same exact thing. I would have to find the sources that I wanted to use and only go by those sources and nothing else.
Yes.
Do not deviate, do not go anywhere else, just keep the blinders on. And it works great for it. However, what I've also noticed is that as the prompt gets longer and longer and longer, it gets slower and slower and slower. And then the prompt that you give it, it tends to deviate from the actual direction you give it, and it does the actual opposite of what you ask it to do.
Yeah.
So the only way to get around this was I had to create I had to make sure I have the solid prompt that it would require for it to do what I wanted to do, and then start a whole new prompt all over again. So I had to keep on, and after like 2 or 3 requests, it would start to bog down again and again and again. But every time I was giving what I wanted, I had to verify every single part of it before I could actually use that information.
That's a great point, and you actually explained exactly why agents are becoming more popular. It's breaking the task down into multiple smaller prompts is a lot more effective than one. The reason why is, so we talked about the concept of context before and the amount of tokens that a model can process at any given time. You'll see like some of these models now, they'll say, hey, we have a context window of, you know, 256K tokens, 1 million tokens, right? So you're thinking, great, I can dump all the data that I want into this particular prompt. The issue is there's a concept called context rot. So the best way I think to explain this is that even if the model has access to all this information, it can process it, it can only still pay attention to a certain amount at a certain period of time. So it's like you know, if you were to give me like a textbook, right? I can't read the entire thing at once. I can only go like through particular sections. So by breaking the instructions down, and even if you don't have like, you know, something with pre-built agents in your own like manual workflows, I do the same thing. Breaking the instructions down into smaller series of tasks greatly increases the accuracy. Absolutely. Yes.
Yeah, and I would just add, when you find a good prompt that works,
Save it.
save it.
Mm.
You know,
Yeah.
put that thing in your happy little letter in your pocket and keep it, and then use it and work it from there. Because usually it'll help you refine even better.
Yeah.
You know, and save it again.
Yep.
'Cause
Yep.
Just
Yeah.
smart.
Definitely. One of my favorite things to do is, along those lines as well, is to do validations with different models. I'll have one LLM fact check another. So if I, you know, go and ask ChatGPT something to do like a research report on something, which it's pretty good at. I'll go and feed it to Claude or Gemini. I subscribe to a lot of these services. I have a problem, and I'll ask them to actually validate the information that comes back, because you can at least again it won't be perfect, but it does give it the ability to have another set of eyes on it, so to speak. It's great feedback. Thank you.